Thank you for joining today's webinar about discovering predictive maintenance management in a digital world. Much appreciated for your time. My name is Kevin Devecioglu. I am the Managing Director of Bimser International. Today with me, I have a great panel of speakers. I have Dr. David Siegel from Predictronics with me, and also we have Dr. Mo Abu Ali from IoT company, and we also have Sam Watt with us from Bimser International as our pre-sales software engineer, as well as we have Hakan Aydoğdu as our product manager of BEAM maintenance management system. And before I get started, I would like you to ask you to mute your microphones. Please keep your microphones muted. And if you have any questions, feel free to type in the chat box. Great. So I think we can get started. So first of all, I'd like to talk about who we are, what we do in a brief way, if possible, about Bimser International, and then I'll hand it over to Dr. Siegel, and we'll learn about predictive analytics and how it is running and how it is actually reflecting on PDX. And we'll basically show you also brief demonstration about how we can all enjoy the benefits of predictive analytics and predictive maintenance. So, Bimser International, we are an enterprise software maker since 1998, and we are based in New York. Also, I need to mention that we are a group of companies. Our software development center and our global headquarters is in Istanbul metro area, where the yellow dot is. We have another company in Europe for our European operations. And us, as Bimser International, we are based in New York. So as a group, we are about 160 people. We are a growing organization. Also, a European Bank for Reconstruction and Development investing in our company. So they are in our board. So with their help and support, we have more visibilities in international markets. Bimser is a certified vendor of Acumatica ERP system, Microsoft ERP system, again a certified vendor, and SAP ERP's certified vendor as well. Also, Bimser is ISO 9001 certified and ISO 271 certified. So since 1998, we have been very focused. We focus on these 4 products. Briefly, EBA is our workflow and document management platform. BEAM, that we'll talk more about today, is our predictive asset maintenance, facility, and energy management system. QDMS is our quality, risk, and compliance management system. And finally, Ensemble is our business process management tool. In addition, we have contract management solution and ITSM solution running on EBA platform. So here on the screen, you can see how we position our products. Ensemble is more of a managerial tool, and EBA with the workflow engine, BEAM with the maintenance management capabilities, and QDMS for the quality management. They automate processes. Our products work on cloud, they work on-premise servers, and they can be linked to any ERP, any CRM platform available in the marketplace. Here you can see how many clients we have globally, and these figures are increasing every single month. And finally, I'd like to talk briefly about our clientele. We work with many different companies and many reputable ones. United Nations is one of our references, as well as Ford, Renault-Nissan Alliance, and 3M, I need to mention. So in a nutshell, that is who we are and what we do as Bimser International. So what I like to do is that, as I mentioned earlier, I like to hand the microphone to Dr. Siegel for him to address predictive analytics and talk about PDX a little bit. And then we'll continue with Dr. Abu Ali, and we'll move on simply. So just like I mentioned earlier, please keep your microphones muted. And if you have any questions, please type them in the chat box, and we'll address your questions in Q&A session. Thank you very much. Dr. Siegel?
Oh, thank you. Yeah, thank you for the introduction. So I want to share about the technology related to predictive analytics and predictive maintenance and how it can be used to improve your maintenance activities and your overall efficiency in your production plants and manufacturing or other environments where you manage your assets. So yeah, usually the key is to focus on some business objective where there's a good value in improving your maintenance and monitoring your assets and taking care of your assets. So that can be avoidance of unplanned breakdowns, reducing maybe unnecessary maintenance, maybe extending your preventive maintenance schedule, as well as for manufacturing applications, relating the process conditions to quality and ultimately reducing scrap or improving quality. So keeping those objectives in mind, then you'll kind of tailor the predictive solution for those purposes, whether it be early detection of symptoms that your machine is heading towards a failure, maybe diagnosis of the problem so you can have a shorter time to repair your equipment, as well as relating the process to quality and the quality prediction as well. So the business objectives also kind of drive the configuration of the templates for the predictive solutions. So yeah, if you go on to the next slide, and this really highlights the value of the solution if used correctly and configured properly. For example, 1 minute of downtime, for example, in automotive factories as example, can cost tens of thousands of dollars. So if you predict and prevent one failure, and that one failure causes an hour of downtime, you're looking at hundreds of thousands of dollars saved by having this predictive solution up and running and used properly. So the general idea is that keeping in mind the business objectives of improving your reliability or improving your stability in your process, the predictive maintenance can really improve your asset health and your management of your assets, as well as if your quality is your focus or objective, it can also be used to improve your part quality as well as reduce defects and scraps as well. So the PDX software is up and running in many organizations and manufacturing as well as fleets and so on. And this is an example of the templates for manufacturing applications. So you'll notice that there's already 10 or 15 templates listed here. There's maybe a total of 25 or 30 different templates. And if you just look at the different ones available for the manufacturing, these include predictive monitoring of industrial robots, predictive solutions for machine tools, including the spindle bearing, the linear axes, as well as coolant and so on, as well as additional use cases on stamping and also auxiliary equipment like compressors. So this is one of the nice things about the PDX software is that these templates are already available. So the ability to quickly configure them and deploy them for your particular application is much faster than what you may find in some other solution offerings. So when we say a template, what we actually mean is actually the entire recipe of how the solution is configured. And this is a good illustration of the 6 steps in the template. To include what data, what sensors are needed, how to gather the data both from external sensors and from the data from the existing sensors from the PLC or the control system, as well as what sampling frequency and other aspects of the data collection we need. Basically, we want to collect the right data at the right quality to meet our overall business objectives. And then from there, the template also includes how to process the data, how to filter the data, as well as how to extract features or patterns from the data. Conditions, that reference condition may be baseline conditions from the machine or when data was collected. And by doing that comparison, you can set process health over time. You could track its key only as a problem developing, is that problem developing, when a fight might occur, so that maintenance action and more proactive, as well as you can take additional steps to diagnosis. This shows the general framework of the templates and how the 6-step process is used. And one of the nice attributes about it is that the PDX software is already integrated into the BEAM software. So once we find early symptoms of machine failure, we can send work orders and other information so people can then address the maintenance issues ahead of time and be more proactive with their management of their assets. So with that template in mind, the next slide will show the corresponding technology and aspects around it. So you'll notice that the PDX stack is our dedicated software for the data collection. The sandbox is what we use for configuring the templates and the predictive analytics. And then we also have the deploy software as well. So this one kind of goes into the 3-step process, or the 3 softwares. The DAC is for the data collection. Our sandbox software is where the templates lie and allow us to quickly configure those analytics and templates for different industrial equipment. And then once that configuration is finalized, we send that to our deploy software, which then runs the calculations and has a really easy and intuitive interface to visualize the results. And that's also where we connect to the BEAM software as well. So this kind of gives you a high level of the motivation, the different steps in the process, as well as the software. And I think the next slide, I'll hand it over to my colleague Mo, who will talk a little bit more in specific about the use cases and also a demonstration of the technology.
Thank you. Thank you, Dr. Siegel.
Thank you so much, David, for the introduction. And Kevin Kursad, I hope you can hear me fine, right?
That is perfectly fine, Mo. Please go ahead. So much. Thank you.
So I want to follow up and continue from David's conversation, and I want to show several case studies of how predictive analytics is deployed in a real environment. And if we proceed through the animation, you're going to see that we have 2 domains of experience. On the left side is our core domain. So most of our projects are conducted inside the factory. So as David mentioned, we have over 25 solution templates, including robotics, stamping machines, CNCs, and so on. And the idea here inside the plant is to significantly impact the OEE calculation. So OEE is overall equipment effectiveness. And by bringing predictive maintenance, we are able to maximize the uptime in the facility, maximize the availability of the machines, which is a critical factor of the OEE calculation. And at the same time, by using predictive quality, we are able to make predictions of when a specific part is going to be a bad part on the machine. And therefore, we can significantly reduce scrap. And adding to that, on the spare parts side, by integrating to a maintenance system like BEAM from Bimser, we are actually able to predictively replenish spare parts. So before the machine actually fails, we could send information to BEAM to request a new spare part, for example, to be shipped to the machine before the machine actually fails. So just imagine reduction in spare part inventory and also reduction in the labor time to fix the machine, because we are telling a maintenance system like BEAM that there is a specific machine, a specific component to fix, a specific spare part to be ordered, and also optimizing the PM schedule, which is available in the BEAM software. So this is a closed loop system that enables the maintenance system and the maintenance process to be conducted in a better way. On the right side is what we call smart product. So if you do not manufacture parts, but you monitor or use parts in the field, so the audience here is your actual customer, your end user. Let's say you make a machine tool, or you're making a pump that is used out in the middle of an oil rig, for example. So here the business case is different. We're using analytics to remote monitor, to predict issues, and to diagnose equipment that is owned by the OEM in the field, okay? And in return, the OEM is offering these analytics as a subscription or as a service to their customers, okay? So ensuring that their customers are satisfied, and the maintenance activities can be governed by a system like BEAM, so that the oil pumps in the field or whatever product you manufacture can be monitored in a predictive way. Closed loop design is very interesting. This is actually feeding data back to the designer of the product. So not only are we looking into manufacturing or looking into the aftermarket service, but we're doing the whole digital thread of the product. We are actually sending data back to the designer so they can improve future generation or future designs of the product. Next slide, please. So I want to show 2 quick examples. The first example is on the smart factory side, looking at robotics. If we go through the animation, David started by saying there's a huge business case in the automotive industry. And this is actually a business case calculation for a large Japanese automotive OEM. Just, you know, in a typical factory, 500 robotics, the average minute of downtime of a robotic is almost $10,000. I mean, I think that number has recently increased as the automotive industry is becoming more and more conservative. But if you notice, robots don't fail very often. There's only about 30 robot failures every year. But each robot failure can actually lead to 30 minutes of unplanned downtime, which is almost $300,000 for the robotic failure. That's a significant amount of lost and unplanned downtime. And with a predictive system, it is difficult to predict all events, but if we only predict 50% of issues or events that are occurring, we can actually save this OEM. And in fact, we have saved this OEM almost $4.5 million per year by just predicting 50% of the failures on 30 robot failures. So the ROI can be significant just by looking at the uptime. This is an example of a realization, actually. We will show it later in a real demonstration, but the system has to be very user intuitive. The main users here are the maintenance organization in this case. And the maintenance people, they are not PhDs and they are not data scientists, and we don't expect them to be that. So by looking at something like this, you're able to immediately look at the health of the machine. Very intuitively, you can see a degradation. You can see the machine's health has entered a warning, which is shown in yellow. You can see a prediction with a prediction window, plus or minus. And you can actually, if you click the animation, you're going to see joint 5 at the bottom. That is actually the specific issue on the machine. And that's the type of information where we can close the loop with a maintenance system like BEAM and inform BEAM or the maintenance system that there is a prediction of failure on joint 5 in the next 2 to 3 weeks, so that the PM schedule will be automatically optimized, the labor to fix the machine will be scheduled, and also the spare part will be ordered. So we're moving immediately from a fail and fix approach to a predict and prevent approach, in this case on a robotic inside a factory. The second use case here is with a large heavy industry manufacturer of tractors and excavators, right? So in this case, I'm not monitoring robots inside a factory. I'm monitoring components on a big truck, which is sitting in the middle of the desert, for example, doing mining, right? It is very costly to send somebody out in the middle of the desert, in the middle of the night, to fix the engine on this machine, right? So predictive analytics even has a stronger business case here. So just imagine if you click, you're going to see a visualization of the different mining sites that Komatsu has, in this case in the Canadian peninsula. And you're going to see that there's 4 mining sites. You're going to see color coding where green is a healthy mining area. Yellow, there's a degradation on some of the tractors. Red, there is a potential failure on some of those mining trucks. And you know, other colors can be also configured. You can see at the bottom there the different components of the mining truck that are being monitored in real time. So in this case, a solution like BEAM could be used to monitor the maintenance activities of smart products that are available around the world in order to ensure that this product, you know, whether it's a Komatsu engine or whether it's an aircraft engine, that this product is running all the time and that spare parts are delivered to that product before the product fails. Because the cost of failure here is significant, and the cost of getting somebody out there with a spare part could actually be extremely costly for the environment. So if we go to the next slide, you're going to see a simple visual actually of the different mining sites. In this case, there is one huge mining area, Canada, for example, with 3 mining sites, and you can immediately see green, yellow, red. What is healthy, what is degrading, and what is failing. And if you click once, you're going to see a zoom in into one of the mining sites where you can immediately see that the diesel engine in this case is actually the biggest issue that is happening on this machine. So a system like BEAM would be informed that the diesel engine is having a problem prior to the failure. So a new component of the diesel engine would be dispatched with a maintenance person to the remote location of the truck in order to fix it before it actually fails. So these are some of the case studies, you know, in Smart Factory and Smart Product that we're able to realize with a very closed loop system that is collecting the data, analyzing the data in real time, predicting issues, and then sending that information to a real-time system like the BEAM Engineering Asset Management System or Enterprise Asset Management that enables optimized scheduling and optimized spare part replenishment to the environment. And if you allow me, I can just show a very brief demo, just to give you the feeling to the team on the call. If you could see my screen, I want to show a very simple demonstration of a robotic factory, for example. So you notice this is a cloud-based solution. It could also run on-premise. And as a maintenance person, I can very quickly see green, yellow, red. I don't need to be a data scientist. I don't need to have an advanced degree. It's a very intuitive approach, like a traffic light, green, yellow, red. And here's an example of a healthy machine. This machine is actually performing very well. The health values with the artificial intelligence and the machine learning running in the background, those health values are close to the baseline, which is green. And as it degrades, it'll start veering towards warning and veering towards red, which is a failure threshold. And the AI is actually able to self-learn statistically what those thresholds are, so that they can be adaptive to the changing dynamics of the process, right? Here you see, this is data actually from an automotive client that they allow us to show for offline data. And here I've hit degradation. So very quickly, I can actually deliver a prediction for this robotic, where at least 2 to 3 week window I have here from October 16 all the way to December 11 to do different things, right? I can send out predictive alerts, which will be sent out prior to the failure through the BEAM system. We could request a new spare part. In this case, spare part for joint number 5 will be automatically replenished through the BEAM system. And I could also optimize the PM schedule, so I can find a specific person who knows how to fix joint 5 through the BEAM system and bring that person out to fix the machine in time, right? So the idea here is we want to maximize the uptime. We want to sustain a very high level of uptime in the manufacturing facility. And we want to make sure spare parts are optimized, and we want to make sure the efficiency of the preventive maintenance process is optimized as well. And as I mentioned, we have over 25 solution templates. I mean, if you look at a CNC machine, we're looking at spindle bearings, we're looking at ball screws, we're looking at the coolant and the alarms. This is an example of a bearing where the predictions here are actually curvilinear in nature. So our analytics recipe that David has shown is able to combine different machine learning algorithms together, and the templates like this can be deployed in a matter of weeks, okay, and integrated in weeks with the BEAM solution, so you can have a predictive enterprise asset management system running in weeks, delivering value to your company, right? So with this, Kursad, I'd like to hand it back to you, and thanks for the opportunity.
Oh, thank you very much. Much appreciated. Thank you for the insights, and thank you also for the use cases, the business cases that you mentioned. Also, I'd like to thank Dr. Siegel as well for the insights and information that he shared. At this moment, what I like to do is that I like to take my time to talk about BEAM a little bit. You just mentioned about the predictive analytics of the activities. So after PDX predicts, how BEAM basically takes care of asset and maintenance management. I have a brief presentation that I like to show, and then I'll hand it over to our software engineer, Sam, so that he can show the system in a brief demo environment with a brief demo session, and then we can continue with our question and answer section of our webinar. So when we look at BEAM, BEAM is actually an asset maintenance, energy, and facility management system. The system is modular, and it is ready to integrate with any systems. It's open to communicate with other systems. Could be an ERP system, could be an MES system, could be GPS, SCADA, or RFID. In this particular case, we have a pretty effective and working smoothly, basically, integration with the PDX system. So PDX basically remotely monitor the health of the machinery. And when the time comes for the maintenance beforehand, months before, triggers the BEAM for maintenance operations, and BEAM basically prepares the team, materials, and the schedule for the maintenance operations. So just like Dr. Siegel and Dr. Abu Ali mentioned, the idea is to have smooth manufacturing operations without having any unplanned breakdown. That is the main idea, instead of fixing what is actually breaking down. We basically maintain the machinery before anything breaks down. BEAM is coming with a workflow engine, so all the activities can be subject to an approval, and all the users, could be an admin user, could be a regular user, could be an operator at the machine, can basically be a part of this system. And BEAM has more than 10,000 ready-made reports, meaning any activities in maintenance operations can be basically reported, and the performance activities can be basically managed and observed, and you can take action. Here is the key benefit of BEAM. So based on what we have been learning from our clients managed to reduce maintenance costs 15 to 20% once they deploy BEAM. And our clients managed to reduce failure 40 to 80%. So these are big ROIs, big feature, big benefits of BEAM. If you think about it in a manufacturing organization, reducing the cost of maintenance activities and reducing the unplanned breakdowns is a huge benefit for any manufacturing organization. As I mentioned earlier, BEAM is modular. Simply, what BEAM does is putting three things together: man, machine, and material, just like a production operation. BEAM has the same mentality, same algorithm underneath. Based on the basic modules that we have, it comes with asset management, maintenance management, spare part management, and personnel management. What I mean by maintenance management is periodic, preventive, and predictive maintenance. And predictive maintenance is basically linked to PDX. And we can also link to any machinery that's actually generating data on a rule base to get the temperature or vibration kind of observations and information on a basic rule-based system to automate the maintenance operations. In addition to the basic modules, there is purchasing management module, energy management module, service after sales module, and dashboard module. And we'll show you in a minute in this webinar. BEAM is multi-language, multi-currency, and multi-location. Multi-location meaning once we deploy BEAM, you can simply access the system from wherever you are, simply anywhere via web browser. And the system is ready to be used in different languages. You can easily utilize multi-currency capabilities of the system. There is also mobile app available. So what happens is, most of the time in the maintenance management team, these team members, most of the time, they're on the manufacturing floor, production floor. So it's hard to get them at their desk. So this kind of tool is a mobile app. Using it on tablet or mobile app basically is going to increase the productivity of the maintenance team. So you can easily request maintenance with the help of the mobile app. You can take pictures while you are at it when you are requesting maintenance. You can also check the checklist if you are doing the maintenance yourself. You can access the calendar to see the shift and maintenance scheduling in terms of what is coming next. There are many references of BEAM. International Paper, Henkel, Unilever, LG are some of them. Also, we have Barilla in food industry. We have Amcor in packaging industry as some of our references. And our references are available in many different locations globally. So in a nutshell, BEAM as an enterprise level asset and maintenance management system, I just shared with you some information about its capabilities in terms of benefits and features. So what I like to do is that I like to hand it over to Sam Watt. He's a pre-sales software engineer at Bimser International, and Sam will be showing you a brief demonstration of BEAM as a maintenance and asset management system, and you'll have an idea of its capabilities and how it can help you manage your maintenance management and asset management activities. Sam, I'll make you the presenter, and please take it away. Thank you so much.
Okay, thank you. Okay, and thank you for joining this webinar. And this is Sam of Bimser International. So now I'm going to show you the BEAM, which is our enterprise asset and maintenance management system. This is how it looks like you log in into BEAM. and you will have a dashboard on your home screen, which you can have your own design dashboard. Since all the widgets, they are movable, you can move down around to the perfect place, and you can resize it. And also, it is modifiable, which means you add or delete any widget if needed. And we can save it, and this is how you can get your own design dashboard. And besides, the widget can interact with each other. Saying on the top left one, we can make a command like clicking on different location. You will see the real-time data will be changed accordingly. And this provides you a table form or in a pie chart or in a bar chart or just a number on the widget. So it helps you and give you a better way to keep an eye on your KPI and the performance of your company. And then we can go to the top left and have all of our available module. So we first of all go into the asset module, and right here, we have a map function that showing you a real Google map, which you can zoom in and out. And we can pinpoint the location of your company. And once you move the cursor on the pinpoint, then you can have some more information of this location. And also we can integrate the GPS that equipped on your machinery or moving asset. Then you can have the real-time location of your moving equipment or moving asset like the truck. Then we can go to the graphical asset tree. And right here, by uploading the floor plan or the blueprint of your facilities or your company, we can pinpoint the location of your asset or machinery. And when you move the cursor on it, you will have the information like the name, the status, the department it belongs. And you will see they are in green color now, which means they are in a good condition. And once it turns into red, which means they're under maintenance. Also, we can click on it and get a quick access to have a work request, which means a maintenance request, or show the history of this asset, or show the asset image. So what you're gonna see now on your screen is the asset tree. It shows the structure of your company in a hierarchy form and saying in this location, New York, and you will see this location have the asset show in this list. And also we can have the asset line here, which means we can combine two assets to perform for a particular single task. Saying I need in this example, it is a truck and the heavy duty crane. So we can combine them and make them into a parent and children relationship. Then we can go back to the asset list. So right here is save all the information of your asset. So we can also use the filter function here and get a quick access to the particular target asset. What information is stored in BIM is you can have of course, the name of the asset, the department, and the serial number and the buying price. Also, we can connect the material that will be used by this asset and some more information like the legitimate information, for example, insurance or in the inspection information, and the picture in BIM as well. You can upload it from the server or from your local computer. And all the handbook or manual can be attached right here under this documents field. And then you can click save, and this asset will be saved in BIM, and you can retrieve the data anytime you want. And as BIM providing over 10,000 ready-made report, so we can have our report generated in BIM, saying this is our asset status report, and we can use the advanced filter on your left, saying I limit the fields to New York location and click the prepare button. Then you will see all the status of your asset in New York location, and you can export this file to PDF, Excel, or images for sharing. And besides you generate the report every time you need it, you can schedule this report to be sent by BIM automatically. With this configuration, you can choose if it is you will receive the report daily, weekly, or monthly, and also have the time configuration here as well. Then we can go to the maintenance module. So right here, once the operational level employees or the staff find something wrong with the machinery, saying the machinery, then they can have a fast request right here and create a new work request right here. We're filling all the mandatory fields like the priority, the asset code, and the type, and some more information, supportive information. And after the work request is created, and the control center or the supervisor or the managerial personnel can create a work order for the work request. So all the work requests you create will be pulled by the system to this work order list automatically. And of course, you can create a new work order directly by clicking the add button and without any work request. So in the work order, you can schedule the maintenance activities of this work order. As you will see on the top right, there will be a planned start date and the planned end date. So saying it's gonna happen on saying July 15th to July 18th. Then we can assign this to a particular responsible person. And any services is needed, we can define it here, saying the services from vendor, subcontractor, or any third party. And we can have the material that will be used by this maintenance activity. And all the costs will be calculated automatically right here. And you can have a better idea how this maintenance activities cost to your company. So when we save it, it will be in the list, and we can also have all the schedule on this work order calendar. This is the one we just created from July 15th to July 18th. So we can click on it for truck 100 and show the detail of this maintenance activities. And they schedule a better idea how you assigned on the maintenance activities in a calendar form. So besides having or arranging the maintenance activity any single time the problem comes out, we can do a preventive or the periodic maintenance right here. So by double clicking it, what you can do is you can define the time period that you carry out the next maintenance day. Say they can be kind in day, week, or month. So saying I will update it to 120 days, and you will see the next maintenance date will be updated accordingly and automatically. And also the used material and the document can attach here for, and then we can save it. And you will see this preventive maintenance will be shown in this list. And also, and then we can go to the material module. right here under this material, you will see all the material that you have in your company will be saved here and put them into a list, and you can add a new one by clicking this add button. And you can have the information stored in BIM, like the name, the code, the serial number, and the brand, the model. Also, you can have the document like the handbook and also the picture of this material. Besides, we can define the warehouse parameter, which means right here we can define the safety stock, and it's helped you to keep the optimum stock or inventory of your company. Saying the mass will be 100 and the min is 10 and the safety stock will be 30. And then we can click this box to keep to allow BIM keep checking on the minimum level. So once it's reached the minimum level, and BIM will send you a notification in the system and through the email. Then we can save it when everything is done. Okay. And also, besides keeping the record of the material, BIM also provide a function to keep tracking the activities or the transaction of the material, saying it's incoming, withdrawing, or transfer from one warehouse to another warehouse. Saying we have more material is coming in, and then we can choose the location and the warehouse and choose which material is gonna to increase in quantity. So what you can do right here is picking which material is going to having more in our warehouse, and the quantity right here saying it will be 45, and the unit price will be saying $125 each, and you can change the currency right here to USD, and then we can save it, and you will see this transaction record will be shown in here. Then next will be the resource, the personnel module. So right here we can add a new employees or edit the personnel information of the employee. So you can have the name, department, the shift, and the wage, and also attach the picture of the employees, and some more personal information like address, education, and work experience can also be stored in BIM. And then we also have this resource occupation calendar. So it shows you all the tasks of particular employees in the calendar. So we can select them and query it. And besides showing the task that they have, we can compare the schedule of among the employee. So you have a better idea how their schedule is, and avoid conflict when you're assigning the task to a particular employee. So it's come to the end of the demonstration of BIM. So, and once again, thank you everyone, and thank you, Kevin.
Thank you very much. Thank you, Sam. It's been a pretty informative demonstration. Short and sweet. I think attendees get the idea of its capabilities and its benefits. So we come to the Q&A session. I have been receiving also questions from attendees. So we'll be addressing those questions one by one. Also, just know that we put our contact information on the screen. So after this webinar, if you'd like to continue the conversation, if you'd like to see a demo of our products, please feel free to contact us. You have our phone numbers and email addresses on the screen, so that we can continue this conversation and we can see how we can help. So let me see what kind of questions that we have been receiving in the chat box, in the private box, as well as the public box. So one of the questions that I here receive is about actually predictive analytics. So the first question is, how accurate is your predictions? That is the first question. Dr. Siegel, would you like to address it?
I think Dr. Siegel might be muted.
Dr. Abu Ali, would you like to address it?
Sure, absolutely.
Thank you.
So, I mean, the accuracy of the predictions also depend on the type of historical data that's being captured and the type of part or product that is being monitored. Of course, each prediction sometimes is done at a 95% confidence interval, so there is a plus or minus deviation. So depending on the type of model that we are using, the prediction accuracy, of course, is impacted. But let me see if David has more to add. David, are you back?
Sorry, it dropped out for a second. Mo, can you repeat the question? So that way I can...
I want to do a quick comment on the accuracy of predictions and how you ensure the accuracy.
Oh, yeah, that's an excellent question. So a lot of it is based on the metrics that you choose. So for the example, the robot example that Mo was demonstrating, our prediction was providing an early indication, several weeks in advance and without any false alarms. But usually there's, I'd say, 2 or 3 metrics that you would like to look at. That includes the false alarm rate, which hopefully you would want to be, 0 or very minimal. And also how early of an indication can you predict ahead of time. And usually for most business objectives, it has to be at least a week ahead of time. So if we're not predicting a week ahead of time, and then it's not early enough. And also if our false alarm rate is, more than, a few, over the course of a year, is probably not satisfactory. But the solution has been, ruled out and, implemented in many different equipment. And for at least the templates that we're offering, we feel pretty confident on achieving that accuracy. Of course, there is some variation from equipment to equipment.
Thank you. Thank you, David. So I also get this question myself sometimes, and also one of our attendees also brought it to our attention. So in terms of connectivity on the production floor, we see sometimes legacy machinery. These are nice running machines, but they are basically legacy machines, right? They are basically old. So if you like to get data from these legacy machines, that is a big challenge that we have been hearing all the time, and also our attendee also share, asking this question to us. So how do we make sure that any old or legacy machinery can basically generate data in a reliable way?
Yeah, I can give a short feedback. So I think that's a good question, because probably the biggest bottleneck in any analytics project is the connectivity to the plant floor. And it's typically due to the fact that a lot of machines are quite old, so we cannot get data from the controllers. Probably the machines do not have Ethernet capability. So it is important to instrument the machine, right? So we, for example, have internal know-how, we have an instrumentation team, and we have hardware partners where we can go to a legacy machine, we can identify the tags that are needed to get from the machine. We can instrument it with hardware. We partner with companies like Advantech, Moxa, National Instruments, and so on and so forth. So we can revive that machine. So rather than retrofitting the machine and paying a lot of money to do that, you can actually instrument the machine with the needed hardware and the sensors and obtain data from very, very, very old equipment. So I think there's a trade-off between the age of the machine and the amount of data you can get from the machine. But I think with the right instrumentation and the right hardware and the right expertise, those very old machines can be connected very quickly to the network to bring data for analytics and for maintenance. So that's a good question.
Thank you, Mo. I'm going to be jumping from one question to another, so they may not be related to each other, but we need to address these questions. So one of the questions that I received is about mobile apps. So it is for both products, both for PDX and BEAM. So can we use these systems together by using our mobile devices. So what would you say, Mo, in terms of using mobile devices to see the health of the machinery, for instance?
Well, yeah, absolutely. I mean, both systems, Predictronics and BEAM, they're fully web-based. They're using latest HTML5 technology. They can run in any browser. And of course, the capability of using a phone as an app is possible to visualize the data in real time. Of course, you have to be within your company's network, infrastructure to do that. And also projecting the data on a big end-on screen, like a visual display on the plant floor or a big LCD, is possible, so that the data can be viewed by the whole organization and they can use the data very quickly. So I think mobility is critical, and having a solution that has a state-of-the-art architecture enables, mobility for both the maintenance system like BEAM and the predictive system.
Yeah, that was a good question. Yes, definitely. I mean, both systems can be utilized on a mobile device, which is very practical. Very practical. I mean, considering being on the manufacturing floor all day long, not at the desk, having these devices in action is a great benefit. Makes things much easier. Let me see. One of the questions that I have is about BEAM and PDX together. So how long does the integration take for these two systems, PDX with BEAM? And what is the technology behind it in the integration, and how quick can it be integrated and go live? So on the BEAM part, on the PDX part, and more, please feel free to jump in anytime you like. Basically, these two systems are integrated with web service APIs. So just like Dr. Siegel and Dr. Aboli presented, simply PDX remotely monitors the health of the machinery, and when there is a need for the maintenance, when it's coming out based on the predictive analytics, simply through the web service APIs, PDX triggers BEAM for BEAM to prepare the spare parts and prepares the scheduling as well as assignment to the related maintenance management team. This maintenance team may be in-house, or maybe a service team, could be a subcontractor perhaps. So that can basically be managed with the web service APIs, and these systems are already integrated. So deploying them is actually pretty quick. Would you like to add anything more on top of it?
No, that's a good question. I mean, it's definitely a phased approach. I mean, there is always a bidirectional need to integrate predictive analytics with a system like BEAM. So maybe in the first phase of deployment, it is one direction where the predictive analytics software is sending information like machine health and spare part requests to BEAM. So it's a flow out. But in a future second step, potentially, there could be a bidirectional handshake where BEAM is also sending the master data, like the list of machines and spare part availability and so on, to the predictive system. So I think if we phase out the implementation, this would also accelerate the effort and accelerate the use of the products. Yeah.
Great, thank you, Mo. Another question is about the predictive analytics. So you monitor machinery, and based on your predictive analytics technology, how about the conditions, working conditions of the machinery? How does it affect your analytics or predictive approach?
Good question for David.
Yeah. I'll take a first stab at addressing this question. So I think it's a very good perspective. And what we like to say is that predictive analytics can work well, but it's best to have an apple-to-apples comparison of the data and sensor patterns over time. So with that being said, there's kind of two approaches. One is that you can collect data, even though if the machine is doing many different processes or operating conditions, you could collect data on the same operating condition, maybe during a routine test, or maybe when it's during a certain cycle that you pull out and collect data. And that's actually similar to what the demo that Mo was showing with the robot. In this case, it's collecting data maybe once per shift when the robot is doing a particular motion. So we're always monitoring it in the same dynamics, the same motion profile. If the machine is, there's also another option to collect data from multiple motion profiles, but then you would just have separate baseline models for each profile, so you'd still be comparing an apple-to-apples comparison. There are, I'd say, other approaches to this challenge, but they're not something that we have not dealt with before, including not just the manufacturing use cases, but also those fleet of assets like for mining and construction equipment as well.
Thank you, David. Thank you. So another thing actually that I think we need to address is the compliance, because most of the companies, especially food companies, for instance, if to be more specific, so they have predictive maintenance procedures actually in their policies when they are complying with SQF or BRC or halal or kosher kind of certifications, basically these standards. So actually deploying this kind of system in terms of predictive analytics and then also the maintenance, predictive maintenance management is going to be also make it easy for them to comply as well, because you can document the activities, you can perform it, and you can basically measure the results in terms of compliance. So that's also important to talk about. Another question that I have received is about the timeline in terms of duration of the activities. How long does it take in terms of running projects, for instance, pilots or projects or any other activities? How long does it take to run them? That is the question. Maybe Mo, would you like to address this?
Yeah, absolutely. I mean, it's kind of a four-step process. In the beginning, we do a discovery. So we would visit the client, get to know the requirements, and we would show more detailed demonstrations and so on. This would lead to a workshop. So during the workshop, we would architect the solution and create a statement of work for the customer. And then this would lead to the pilot, which we would call a proof of value, because there is a detailed business case behind it, right? So we're deploying technology to deliver a business case. So during a proof of value, typically the software is deployed at no cost, but there is a cost for the services and the training, and we try to keep it minimal. And we would run the pilot for 1 to 3 months. Typically, we then have a business case to justify the future investment, and then there will be typically a subscription approach to the product. So the pilots would run, on average around 3 months, and we would keep the costs minimal to ensure a business case is delivered to the customer. Yeah.
Great.
I hope that answers your question. Yeah.
Yeah, I believe so. I can just add on in terms of BEAM. It is also actually pretty quick to deploy. We also have a demo environment for users to try around if the PDX process is done, of course, in this particular case. And the deployment takes 1 to 3 months. 3 months, depending on the customer's data readiness and availability of the customer's team members for training, basically. So, that's basically important information to share. Another question that I have received it is about BEAM. So the question is about the spare part management. So spare part management is very important. Does the BEAM run standalone, or does it have to work with an ERP system to run the inventory system? That is the question. So I can address that. So first of all, BEAM is actually designed to run independently, standalone. In addition, as I mentioned during my presentation, the system is ready to communicate with any other systems. PDX is one of them that we are communicating with integrations. In addition, we can communicate with any ERP system, manufacturing execution system, GPS, RFID, and barcode, and so on. So the communication channels of BEAM is all open, simply, and it's also open for the ERP system. So if you have an ERP system running, and if you keep your inventory there, basically ERP will be the master data, and BEAM will be pulling the master data information onto its database, let you use it for the maintenance operations, and once maintenance operation is done and ticket is closed, the recent status of the inventory, spare part inventory, will be sent back to the ERP system to keep it updated. That's a typical way of running this integration with an ERP system. If you do not have an ERP system, and if you like to use the spare part inventory management system on BEAM, you are more than welcome to do so, because independently BEAM can run and help you manage your spare part inventory to have the optimum level of inventory, simply. Let me see if I have any other questions. Well, our time is actually almost done. I'm also checking my chat box at the same time. Yeah, looks like I have, yeah, I think I shared all the questions that I have received. Okay, great. So when we are finishing our webinar, David, Mo, would you like to say anything else in addition to what we talked about?
From my side, no, I just want to thank you for the opportunity to collaborate with BEAM. And I think most maintenance systems, EAM systems are quite traditional in the approach. They are more focused on, improving the process behind maintenance and the spare parts and so on. But our vision with BEAM is to have a solution that is artificial intelligence enabled, that is predictive enabled, and that allows, I would say, the use of analytics in a very intuitive way to help maintenance users get the most out of their maintenance system. So really appreciate the opportunity, Kursad, and I'll hand it to David for some concluding words.
No, Mo, I think you really hit it on the spot. I think these types of technologies are really hand in hand and are great in terms of integrating the solutions together, because the predictive solution should help you manage your assets better. So it only makes sense to feed the information to each other system so they can be enhanced and as you mentioned AI enabled. So I thank everyone again for the opportunity, and we look forward to supporting you on your efforts on this improvement in your maintenance and asset management.
Thank you very much. Thank you, David. Thank you, Mo. Also, I'd like to thank you for your time and for your insights. Much appreciated. I'd like to take our attendees and our panel. As I mentioned earlier, our contact information is on the screen at the moment. You can see our phone numbers and you can see our email addresses. So if you have any further questions or if you'd like to continue the conversation, please feel free to contact us. We'll be happy to help you. And we'd like to thank you for your time and for your interest. We look forward to seeing you in our coming webinars. Thank you and have a nice day.